Your homework is to watch these videos if you have not done so already. This concept of ionic bonding is crucial. If there is one concept that you will use daily throughout the rest of the year, it is naming and formula writing. This is step one of every process we will use throughout the year. You have to write a compound to write a reaction. You have to write a reaction to calculate the amount of products. You have to calculate the amount of products in order to find a percent yield. You have to find a percent yield in order to pass your test. As you can imagine, step one, if you can't write the equation, if you can't write the compounds of the equation, this class gets more and more complicated if you never learn step one. What that means is if you hit a bump at any point when we're talking about naming and formula writing, you hit something that you don't quite understand, don't wait to get help later. Get help immediately. If there is any concept that you don't immediately understand when it comes to naming and formula writing, get help. Get out your tutorials pass. Come before or after school. Send it in Modo message. Go look for a video. Do anything you can do to make sure that this comes very easily to you. Because if this comes easily to you, this course will come easily, okay? So make sure you watch these videos and you are actually watching them. You're sitting there taking full attention, paying attention. I realize that they're educational videos. They're not what you want to be spending your time on YouTube doing, but they are what you need to go through if you're going to really get these concepts down. So ionic compounds, formulas, and naming. An ionic compound is a compound that is formed between a metal and a nonmetal. An ionic compound is a compound that is formed between a metal and a nonmetal. Metalloids can be used in ionic compounds, sometimes as cations, sometimes as anions, depending on the properties of the specific element. In ionic compounds, the metal will always be a cation, and the nonmetal will always be the anion. When forming ionic compounds, the goal is to balance the number of positive charges with the number of negative charges. More specifically, you want to ensure that the number of electrons that the cations are giving up is equal to the number of electrons the anions need so that they both have full outer energy levels. Remember, that is how an element becomes stable. That is how they react. That is how they form their ions. So let's get some mental pictures behind this first. If I have sodium, which has one valence electron, and I have chlorine, which has 7, chlorine is more electronegative, which means it will steal this electron to here. When this happens, sodium now has a positive charge, chlorine now has a negative charge, and because this has a positive and this has a negative, these two are stuck together. We call this an ionic compound. They're stuck together, and we would name this with its formula. We have one Na and one Cl. So NaCl, which is also called salt, table salt. Now if I had Mg and Cl, now notice it doesn't matter where I leave the dots. Mg has 2 valence electrons. Chlorine has 7. Chlorine is more electronegative, so it will steal this electron, giving it a negative charge. Chlorine has no space to steal another electron. So what happens is if there is one chlorine, there must be another chlorine nearby. So another chlorine comes flying by. It also has 7 valence electrons. It is still more electronegative than magnesium, so it steals magnesium's other valence electron. It becomes negative. Magnesium is now 2 positive. All of these are now stuck together, this 2 positive and these 2 1 negatives. If I was to write this as a formula, I have 1 magnesium and 2 chlorines. Okay? Now if I had a potassium with its 1 and a nitrogen with its 5. Nitrogen's more electronegative. It can steal this one. And this potassium has no more to lose. It's now positive. But nitrogen's not satisfied yet. If there was one potassium, there will be another. This nitrogen will steal that one as well. And this one becomes positive. And then the nitrogen is still not satisfied, so another potassium comes by with its valence electron. Nitrogen steals that one, which gives this one a positive. This nitrogen is now 3 negative, and all of this is together as a compound. It's all stuck together as this positives and negatives. If I was to write the formula here, I would have K3, because there's 3 potassiums, and 1 nitrogen. Okay. If I have boron with 3 valence electrons and sulfur, which has 6. Okay. Sulfur is more electronegative. Sulfur will take this one. It goes here, and it can take this one, which goes here. Now this boron, the sulfur, is now satisfied as 2 minus, but this boron's not satisfied yet. So if another sulfur comes by, it can take this one. Now this boron is satisfied, has 3 plus, but the sulfur is not satisfied. So another boron comes by. And as you can see, this starts to get more complicated whenever we have a different number of valence electrons. So instead of completing this one, which you can and you'll see, you end up with 2 of these and 3 sulfurs. There's a much simpler way to figure out this formula. So this was our visual for how these formulas come to be, and this is what is literally happening. But instead of having to draw out this long, complicated system every time I say this metal and this non-metal react, why don't we use these charges that we already know are going to be formed? We already wrote these charges on our periodic table. We know that every one in the alkali metal is going to be a +1. So we can see how those positives and negatives interact to form our formula. So let's look at our rules. My first rule is going to be to write the cation symbol and then the anion. So the metal, then the non-metal. Just like how they are on the periodic table. Metals are on the left, non-metals are on the right. So you're going to write them in the same order we have them on the periodic table. Then look at the periodic table and find the charge of the ions. From those charges, you should be able to figure out those subscripts without having to draw everything out. So figure out the subscripts. We're never going to write 1 as a subscript because that's understood. Just like if you are in math, you don't put 10 to the 1 power. Everything to the 1 power is itself. Why would you put something to the 1 power? So we have 2 options for how to figure out our subscripts. Option 1 is to use logic. If it's a +1 and a -1, I need 1 of each. If it's a +2 and a -2, I need 1 of each. A +2 and a -1, I need 1 + 2 and 2 -1s. If that works for you, just logicking out how do you cancel out these charges, use option A. If that one doesn't work so well for you, then I want you to do the Superman. Point up with both arms, straight in the air. Take both these arms, everybody do it. Take your 2 arms and create an X, cross them. This is what we're going to do with the charges, okay? So you put the charges on top, you take those numbers from the charges and cross them down to the bottom of the other atom. So that's called cross and reduce. We're going to cross the charge number to be the subscript. Okay, take the charge numbers and cross them to be the subscript, and we'll reduce it if possible. So let's do some examples. If I was told to write the formula for barium and sulfur, we write the metal first and then the non-metal. Barium's my metal, so I put barium first, then the nonmetal sulfur. Then I look at their charges. Barium is 2 plus, sulfur is 2 minus. If you want to use option A for logic, if I have a +2 and a -2, I need one of each to balance it out, and my formula will be BAS. If you don't want to do that one in your head, that's totally fine. Instead, we can do the cross and reduce. Take each of the 2's and cross them to the bottom of the other. So take the charges and cross them, which would give me Ba2S2, but I don't really need 2 of each, so we reduce if possible. This Ba2S2 reduces to BAS. So no matter what, you get the same answer. So let's do some more examples. If I have potassium fluoride, I write the metal first. Potassium's my metal. Fluoride is my nonmetal. Potassium has a +1, fluorine has a -1. Option A, use logic. +1, -1. I only need one of each to cancel them out. Option 2. This is a 1 and that is a 1. I take those 2 charges and I cross them. That gets rid of the charge on top. K1F1. Now we don't leave 1s as subscripts, so instead I'll get rid of that. KF. No matter what, you get the same formula. So bromine and magnesium. Write the metal first, just like on the periodic table. The metal is magnesium. Bromine is the nonmetal. Magnesium has a 2 charge. Bromine has a 1 charge. If I look at these 2 charges, you can either use logic. I will need 2 of these for every one of those. Or we do the cross. The 2 comes here. The 1 comes here. We don't ever leave 1 as a subscript. Now I can't reduce this, so this is my formula, MgBr2. So strontium and phosphorus. Metal first. Strontium and phosphorus. Look at their charges. Strontium has a 2 charge. Phosphorus has a 3 charge. Logicking this one out might be a little bit difficult for you. If you can do it, that's totally fine. If this has a 2 charge and that one has a 3, I will need 3 of these and 2 of these. Or do the cross and drop. So if I take my 2 charges and I cross them, the 3 goes here, the 2 goes here. That gets rid of the charges. You get SR3P2. So to name an ionic compound, we just figured out how to write the formula. Now we have to name it. So in order to name it, first for the cation, you just write the name of the cation. In other words, write the metal. There's absolutely no change to the cation. Write the metal's name. Then for the anion, just like how we wrote anions, the ion name, we change the N to "ide." For the anion, you change the N to "ide." Just like a chlorine ion is chloride, well, it's an ion inside this ionic compound. So now it would be "ide." Change the root name of the anion, take the root name and change the end to "ide." So if I have my cation is barium, and my anion is sulfur, and just like we used as our first example, Ba is barium, so we just write barium. S is a sulfur, which as an ion is written as sulfide. So the name is barium sulfide. That's all there is to naming it. So below, for numbers 1 through 17, you'll look at writing the formula. For numbers 18 through 32, you will write the name. Your homework ends right here.